Hello, grade 11s. We're on to Sine Law tonight. I must admit some of you are looking kind of funny in your pajamas tonight. Let's figure out this triangle. When I want to find various measures in a triangle, we have started with right angle trig because that's where trig ratios were discovered. And I am going to extrapolate from there and put it onto a triangle that is not a right angle triangle. So originally, if I had two angles of 40 degrees, 60 degrees, and I wanted to find the measures of the other two sides that are missing, I have the 15 meters. I don't have a triangle that's a right angle triangle. So our strategy would be to drop a height perpendicular to the base, find that length so I can use SOHCAHTOA, and then use that to find the other sides. So let's do that for a moment. I'm going to start with the right side triangle. No, I'm not. I lied. I'm going to use the left side triangle because I have more information there. I'm going to label my sides as I always should, the hypotenuse, opposite, and adjacent. It's unfortunate that we often use height with a small h, hypotenuse with a capital H, and it can get a little confusing, but I want to find my opposite side and adjacent side of that left triangle. So I am going to call the adjacent side little x because I'm stuck with letter choices. Let's find both of those missing sides. To find the opposite or height, I am going to use the sine ratio. Sine of 40 degrees is opposite over hypotenuse. That would be height over 15. So I'll find my height of that particular triangle as 15 times sine 40 degrees. Okay, let's do this together in real time. Make sure your calculator is in degree mode. 15 times sine 40, 9.6 for the height. I'm also going to find side x while I'm working on that triangle because I want to find all the missing sides and angles. To find side x, I'm using the same opposite, adjacent, and hypotenuse, so I'm going to use the cos of 40 degrees, which is adjacent over hypotenuse, so I'll use x over 15, so the length of x is 15 times cos 40. So the length of x on the bottom, which is only a portion of that side, is 11.5. I'm going to go to the right side of the triangle now because now I have the angle of 60 degrees and a measure 9.6. So I can find the missing sides. Okay, I'm going to get rid of that red for a moment because I don't want us to get confused. The right triangle, I should label the sides of that one. Hypotenuse is the longest side across from the 90 degrees, opposite to the 60 degrees, and adjacent. So if I want to find the hypotenuse side AC, I am going to use the 60 degrees opposite in hypotenuse, so sine. Sine of 60 degrees, which is opposite over hypotenuse, is the height, which is 9.6 approximately, over the hypotenuse side, which is AC. AC is on the bottom of my ratio, which can be a little tricky, so we're going to multiply both sides by AC and then divide both sides by sine 60. Remember, there's always a division when your variable's on the bottom. Make sure you are good with your calculator. 9.6 divided by sine 60, and I have 11.1. So I have one of the missing sides. I would like the entire bottom length as well and the missing angle at A. So I have part of the bottom. I have 11.5, and I certainly can't assume that it's the middle. It isn't. So I want to find the adjacent side. I'm going to call it Y. We could have labeled it a little differently, called this point D, for instance, and then talked about BD and DC. But I'm just going to call it Y for this particular example. Let's find the adjacent side. We want to use cos of 60 degrees. Adjacent over hypotenuse would be Y over 11.1. I could have used tan and used opposite over adjacent. Y equals 11.1 approximately times cos 60 side y. 11.1 cos 60. 5.6. So the side BC is the 11.5 and the 5.6 added together. And I have rounded both of those. 17.1 approximately. The missing angle, we would add to 180, so the missing angle is 80 degrees. Okay. We did that quickly using SOHCAHTOA. We didn't write it very formally, but I want to use those same numbers. There they are, a little less rounding going on. Same triangle, not proportionally drawn, but there it is. And we want to remind you of another strategy you have when a triangle is not a right angle triangle. You can drop a height and make it so, or you can use the sine law. Sine law is a relationship between angles and their opposite sides. Triangles are all about opposites. So this angle and that side, this angle and that side, this angle and that side. Notice that the smallest angle is across from the smallest side, largest angle from largest side, middlest from middlest, and that makes sense proportionally. The sine law, if you have a good memory, is sine of A, angle A at the top, across from little side A at the bottom, is equal to proportionally sine of angle B across from little b equals sine C over C. We can check that that is true. Is it true that sine of 80 degrees over 1706 is equal to sine of 40 degrees over 11.13 is equal to sine of 60 degrees over 15? Because we've introduced rounding errors, I'm assuming these will all be just a little hair off, but you can see that the relationship will work. Let's do the first one first. Sine of 80 divided by 1706, decimal 0577. Sine of 40 divided by 11.13, 0.0577. Interesting. And lastly, the sine of 60 divided by 15. Awesome. Sine law. We need to write that on our cheat sheets and really commit it to memory. You can use the entire sine law upside down if that is easier to solve. Let's try this one. We've been asked to solve for side A. Remember that big angle A is across from little a, big B across from little b, big C across from little c. That just reinforces the fact that solving these triangles, we're thinking about opposites, especially with the sine law. So let's set up the entire sine law, even if we don't want to solve for all of it. Sine A over A equals sine B over B equals sine C over C. Sine A over A, don't know, don't care, but I always start by writing it all down. Sine of 62 for B over little b is 15 equals sine C over 13. And I lied to you just then, didn't I? Sine A over A, we do care about that. Sine A quite profoundly, really. All right, equals sine A over A. Well, at the moment, I can't solve for angle A or side A. There's too much missing information if I were to try to solve that ratio. Two unknowns. I couldn't do that. So I am going to look to the right, and I am going to solve for angle C. Once I have C, and I already have B, I can find angle A and work from there. To solve for angle C, we do as we always do when we're solving. We are trying to get something alone. So if I want, and I'm only looking at these two right now, if I want to get sine C alone, I need to get rid of the divide by 13. So to get rid of divide by 13, we multiply both sides by 13. My right side becomes just sine C. My left side is 13 times sine 62, all divided by 15. And we'll use a calculator for that. Decimal 765, There we are. If I want to find an angle and I have the decimal, now we're dealing with triangles, so it's all acute. We are going to find angle C by taking the second function sine of both sides. And I know for sine I want a decimal less than 1. Second function sine of decimal 7652. 49.9 degrees. C is approximately 50 degrees. So if I know C and I already know B, I really know angle A because all triangles add up to 180. So angle A is the difference of 180, 50, and 62, which is 68 degrees. 68 degrees. So in my sine ratio, I know for sine A over A, I can replace that A with 68 degrees. So I want to solve now sine 68 over A equals, and I'm going back to the ratio that I know entirely, sine of 62 or B over little b, which is 15. So I'm going to solve that ratio now and find the A that I was looking for. We have a problem when we have the variable in the bottom. We need to multiply both sides by A and both sides by 15 at the same time. Some of you say cross multiply. All right, next line. Multiplying both sides by 15, I get 15 times sine 68. And on the right side, I'm going to multiply both sides by A. I'm going to get A times sine 62. To get A by itself, I'm going to divide both sides by sine 62. 15 sine 68 over sine 62. Now I'm going to touch my calculator and I will get my answer for A. Approximately 15.8 for side A. We're going to find the height. Last example. But this time, my height is going to drop down onto the only length that I know. So I can't use that length to find height directly using the angles that I have and SOHCAHTOA. I'm going to need to use the sine law on the larger triangle and then use SOHCAHTOA on one of the two smaller triangles with the height in it to find the height. So considering the triangle ABC, I would like to find the length of AB or AC. So I'm going to set up the sine law. Sine of angle A over 2.9 equals sine of 5.9 degrees over little b, which is over here, equals sine of 10.3 over little c. Okay, it appears that we don't have enough information to solve this, but if I have 2 out of the 3 angles, I really do know the third angle. So we can replace that angle A with the appropriate angle, and I'm going to do that work off to the side. Angle A is equal to 180, subtract the 10.3, so it's an obtuse angle for sure, minus 5.9 degrees. I am left with an angle of 163.8. Okay. It doesn't matter which of those two sides that I find. I could use either the little b or the little c to find the height. So just because they're proximate, I am going to use these two. This ratio will allow me to solve for b. So our variables on the bottom, we're going to need to multiply both sides by b and by 2.9 to get rid of our division. So we have b times sine 163.8. And when we multiply both sides by 2.9, I have 2.9 times sine 5.9 degrees. One more step before I touch my calculator. I'm going to divide both sides by sine of 163.8. And when I type that in for side B, B is 1.07. Once I have side B, I can use that triangle on the right to find the height. So I can label my triangle, the little half triangle where I've dropped the height, with opposite, hypotenuse, and adjacent. Don't care about the adjacent side. It's some portion of 2.9 kilometers, but I want to find the opposite, the height. So I am going to use sine of 10.3 degrees equals opposite over hypotenuse, the height over the 1.07 kilometers that we just found. Multiplying both sides by 1.07, I have found the height. And it is approximately 0.19 kilometers. I've laid out some homework for you, page 319, 1, 6 to 10, and 12, and you are familiar with the sine law, so I don't expect these will be a problem. So make a good stab at those, and then oddly, I would like you to go to pages 312 to 313, and there is an example where two different people have done diagrams that are different. Could you please draw their diagrams and solve it using each of those two different diagrams, and you'll get two different answers, and decide which diagram would be correct. This will set us up for tomorrow's lesson.